Continuing with this, we will look at the next section, chapter 8, in fact, which is already, as we said, is about, oops, where am I? Yeah, I just jumped a little ahead. So we finished these, chapter 7, and we are looking at nature-based solutions to achieve water resilience in cities. So we already discussed the nice figure here. These are nice. I included them just because they are so indicative of what is being discussed. So in chapter 7 we look at dimensions of nature-based solutions for water resilience. So we talked about sets: ecological, technological, and social. So we are looking here at ecological, technical, small and distributed, and large and centralized. So you have color coding here: brown, green, turquoise, and blue. So that will feed into some of the figures that actually I already not going to include that figure here, but anyway, we'll come back to it. Examples of nature-based solutions for water resilience with key dimensions and functions characterized. So type of NBS: bioswale, rain garden, rainwater harvesting, intact wetlands, park and restored floodplain. We will have some more. I thought that table has more, but did I misplace it? No, I didn't. Okay, so that's that. Dimensions: eco-techno hybrid, green and brown, smaller and distributed. So you have technologies being, or green technology, brown technology. So whatever the color coding that's being used, I'm not being very careful here. Maybe I should. Give me a second here. Let me pause this. So I'm just going to I'm staring there because I started recording. I was just trying to make sure I was recording. So I'm going to be a bit lazy and just read these from the text itself. So there are several axes or dimensions along which NBS can be organized. So here we are talking about the ecological element categorized using blue, turquoise, green and blue colors. This is the spectrum. This corresponds to the way that soil, vegetation and water elements are combined, and the hydro period or pattern of water inundation is dealt with. Okay, so blue NBS are aquatic features focused on primarily providing water storage and conveyance. That's blue. Green NBS are terrestrial NBS with soil and vegetation. So that's green. Key water-related functions of these NBS include infiltration, evapotranspiration, and water quality improvement, and they may provide temporary storage of water during storm events. Brown NBS then are not often acknowledged in most NBS codifications, but they are terrestrial NBS that include soil-based and minimally vegetated features such as fallow gardens or vacant lots. So you can think of it as a desert color, dry soil color. Okay. So brown NBSs are more prevalent in arid regions where most vegetation requires water inputs, and they are still able to provide critical water-related services such as infiltration, temporary storage of water, and water quality improvements. Turquoise then are a function of mix of green and blue NBS and include soil, vegetation, and water with varied hydro periods, with wetlands being primary type. Okay, so that covers all of that, and then the technology axis is the other one. So keep those in mind. I'm not going to map those back into the points here, but you should follow up. So if you are talking about bioswale and rain garden, you have eco-techno hybrid, green and brown, smaller, distributed being the dimensions. Designed function is for flood management, water quality treatment, and ancillary functions or co-benefits are in terms of aesthetic benefits and habitats for additional species of birds, insects, butterflies, and so on and so forth. Okay, so rainwater harvesting can of course help with flood management and drought management, has additional value of aesthetic and recreational benefits. And intact wetlands, the designed function is not applicable because that's already serving its purpose and has dimensions of ecology, turquoise, and smaller or larger depending on the size. cities, but it has ancillary functions in terms of flood management, water quality treatment, and habitats. They're very good for migratory birds most often. So even in a city like Mumbai, a mega city, you have flamingos coming every winter. As of now, there are flamingos out there worth visiting. Parks, so they are again recreational, but they also help flood management, habitats, and urban heat reduction, especially for those who don't have their own green spaces or air conditioning and so on. Restored floodplains help with flood management and also help habitats and recreation. So here are examples. Wetland nature-based solutions in Chilean cities. We already looked at Valdivia before and how they used wetlands. So map of Valdivia, Chile, with its land cover and drainage system demonstrates its extensive wetlands that are officially incorporated into its stormwater management system model. So they have used NBS in that sense. A photograph demonstrates a channelized wetland that acts as wetland storage for and conveyance away from a medium density residential and commercial area in Valdivia. And in C, we are looking here at in Concepcion, Chile, Los Bartros Urban Wetland Park in San Pedro de la Paz demonstrates efforts to create public access to enjoy the wetlands. So you create walkways so that people don't wade through the wetlands and they are protected. The Rucoant Andelian wetland shows an intact wetland adjacent to an urban development here. Hopefully connectivity from this hill to this wetland was not lost because of these constructions. So you can never pay enough attention to the integrity of ecosystems in that sense, but when they do something, that's less of a bad news than necessarily great news. Okay, so NBS implementation in the Old Town area of Zhenjiang. A lot of good examples from China that I'm actually not showing all of them. So sorry for the poor quality of the figure here, but this is a schematic of the sponge development plan of Zhenjiang, a 22 kilometer square demonstration zone. You can see the various drainage areas of systematic sponge development. There is a lake for water source preservation, drainage network upgrades have been done, stream restorations, sewage plant, wetland ecological restoration, sponge retrofits for 8 flood-prone areas, 5 stormwater pumping stations here, and 60 neighborhood sponge retrofits. You can see specific pavements here with rain gardens, wetlands mixed in nicely with the urban development in the background, and the parks and public accesses to various of these NBS zones. Okay, so future concept vision for cloud burst management at a pilot location in New York City with multifunctional NBS serving as recreation space, as recreation spaces on dry days and as stormwater detention spaces on wet days. So you have cloudburst. If you don't know what that is, that's just a massive amount of rain in a very short period, as if somebody just poured a bucket over rather than clouds raining. So during dry days you can see there is games being played, shared space with greenery around. On wet days it becomes stormwater detention space, and you have similarly here recreational area with kids and older people and singles and couples enjoying the green space, and on a wet day this will become a detention space. So this is a very nice nature-based solution to manage severe drought in Melbourne, Australia. Okay, so this is I'm combining here the New York City example with Melbourne, Australia, which hopefully is in the next figure, maybe not. So I screwed that up, scratched this part here. So let me leave this here and come back to the next chapter, which is on so I have to be careful to see what chapter it is and what the painting the piece of art is trying to represent. So this is human physical health outcomes influenced by contact with nature. So how NBSS actually can help. So here we looked at this before a little bit, kids doing stargazing and maybe some biodiversity or exploring insects and other things. There is a lady doing her yoga here. There is a mother sitting with the baby and enjoying the greenery. There's another lady doing some exercise, people relaxing, older people having their 3 cups of tea per day, and somebody taking a jog. So there is plenty of evidence that exposure to green spaces and nature has tremendous health benefits. So we'll come back and look at that in the next chapter. But I hope in chapter 7 you got a good sense that NBSS can be used effectively and efficiently to serve for water resilience in urban centers. All the paving in urban centers, even for the same amount of rain, can create heavy runoff because there is no soaking into the soil because of the paving. So unless you design bioswales, permeable pavers, green spaces, rain gardens, and the NBSS that we talked about, wetlands and so on, you will have problems of runoff, loadings of nutrients and sediments and so on, which can have very bad impacts on groundwater or on coastal waters and so on and so forth. So we'll come back and look at health outcomes of nature-based solutions through exposure to green spaces. Okay?